Hey guys, so on your table of contents today, we're going to do these lessons with me in class, but this is for if you were absent. So my table of contents, I'm on page 47, and we're talking about parallel and perpendicular lines. So once you have that written, if you will just go ahead and flip to that page for me. And I did have some stuff already filled out for you. So if you'll pause the video and go ahead and let me zoom this out. If you'll write your title and write those three things for me. Those are the three things that we need to know about today because we're talking about parallel and perpendicular. So pause and write that, and as soon as you unpause, you're going to hear me going over them. Okay, parallel lines, these are lines that never intersect. Okay, they have the exact same slope. This is what is so important for you to memorize and for you to know, that they have the exact same slope. Okay, since this is math, we always have symbols that we can use. So if you don't want to write the word parallel, we use these two slanted lines that look like parallel lines. And I tend to draw mine a little bit longer than the line is because sometimes they look like ones. Okay, perpendicular, these are lines that intersect at a 90-degree angle. So it would be lines like that. That would be a perpendicular line because that's at a 90-degree angle. And what is so important for you to know is that they have opposite reciprocal slopes. Okay, y'all don't know what opposite reciprocal is yet. We're going to find that out in a minute. And when you're talking about perpendicular, we use an upside down capital T for the symbol. So you'll see me use the symbols more than the words, just because it's easier to write the symbol than to have to spell out the word. Okay, now an opposite reciprocal, this is that new thing for you. What an opposite reciprocal means is you're going to take the opposite sign of whatever you have and you're going to flip the fraction. That's just all an opposite reciprocal is. Change the sign, flip the fraction. So the first thing we're going to do is do 5 examples of opposite reciprocals. Now, this is not going to be like your worksheet today. What you're going to actually have to do is tell me if they're parallel or perpendicular. But you can't do that unless you can do this part. So when we're talking about opposite reciprocals, so if I have 3/4, I need to change the sign. Since this is positive, I make it negative, and I flip the fraction. Since it's 3/4, I make it 4/3. That's an opposite reciprocal. Okay, for example 2, I have 2 and. So first thing I'm going to do is actually make this a fraction. I'm going to make it 2/1. Then I'm going to change the sign. I'm going to make it negative, and then I'm going to flip the fraction, 1/2. Okay, for -7/8, it's already a fraction, so I'm going to change the sign. I'm going to make it positive. You don't have to write a positive sign, and you're going to flip the fraction, which would be 8/7. For 1, this is technically just 1/1. So when you go to flip it, you can do negative because you have to change your sign. But when you go to flip the fraction, you're still going to have 1/1, or you can just put -1. Now, this last one is a tricky one. If you have a slope of 0, so I'm going to come over here and I'm actually going to draw me a graph really quick. This is X, this is Y. Okay, if I have a slope of 0, slope goes this way. That's a 0 slope. Okay, to get a perpendicular, an opposite reciprocal, you would have to have a line that goes like this. And so this would be my perpendicular line. Well, that slope is going up and down, so therefore that means it's an undefined slope. Okay, you're going to solve some of these and you're going to get 0 and undefined, which is okay today, but you just have to be able to tell me if those are parallel or perpendicular. So if you want to, I'm going to display 5 examples. I'm going to do this all in the calculator. I'm going to show just a little bit of work and do all the work in the calculator, and then we have a couple examples on the back. So when it says determine if the slopes are parallel, perpendicular, or neither, you're going to use the formula m equals y2 minus y1 over x2 minus x1. Okay, so this is going to be my first equation, and this one's going to be my second one. So every problem, I'm going to have 2 problems on this. I'm going to do x1, y1, x2, y2, and I'm not going to rewrite that because it goes down. So I'm going to do 2 minus 3 over 6 minus -2. I'm going to draw me a little squiggly line, and then I'm going to do 3 minus 0 over 3 minus negative 1. So the first problem, the second problem. Now I'm just going to grab my calculator, and I'm going to do alpha y equals, we're going to do 2 minus 3 over 6 minus negative 2. And that gives me negative 1/8. Then I'm going to do the other problem. Alpha y equals, enter 3 minus 0 over 3 minus negative 1. And that gives me 3/4. Okay, so now what I do is I'm going to look to be parallel. They have to be the exact same slopes. These numbers are not the same, so they're not parallel. To be perpendicular, they have to be opposite reciprocals. That means they have to be opposite signs and a flipped fraction. That didn't happen either. So this is a neither problem. They're not parallel. They're not perpendicular. Okay, now I'm going to move to my next problem, x1, y1, x2, y2. And I'm going to do 4 minus 2 over 5 minus 0, squiggly line, 3 minus 8 over 3 minus 1. Okay, alpha y equals 4 minus 2 over 5 minus 0, and I get 2/5. Alpha y equals 3 minus 8 over 3 minus 1, and that gives me negative 5/2. Okay, first thing I look for, are they the exact same answers? And no, they're not, so they're not parallel. Are they opposite signs? So one's positive and one's negative. And does the fraction flip? Yes, it does. So these are called perpendicular slopes. Okay, x1, y1, x2, y2. That's the last time I'm going to write it. So if you keep writing it on your problems, we're going to do 6 minus 8 over 2 minus negative 1. And we're going to do 3 minus 2 over 3 minus negative 1. Okay, alpha y equals 6. Whoa, wrong button. Alpha y equals 6 minus 8 over 2 minus negative 1. That gives me negative 2/3. And then I'm going to do 3 minus 2 over 3 minus negative 1, which gives me 1/4. Okay, so now I look at these and I am looking to see if they're the exact same, which they are not. And then I look to see if they're opposite reciprocals, which they're not. So again, I get another neither. Okay, for my fourth problem, we're going to do 7 minus negative 2 over 0 minus 0. And we're going to do negative 5 minus negative 5 over 6 minus 3. You can do 7 minus negative 2 over 0 minus 0. And when the calculator gives you error, remember that that means undefined. Okay, so we could just hit quit, and we're going to do alpha y equals again, negative 5 minus negative 5 over 6 minus 3, and that one gives me 0. Okay, if you reference up to your notes up here above where we did opposite reciprocals, do you remember how 0 and undefined are opposite reciprocals? Well, if they're opposite reciprocals, that means they are perpendicular. Okay, for my last example of this style, we're going to do negative 4 minus 1 over 3 minus 3. And we're going to do 5 minus 1 over negative 4 minus negative 4. Okay, alpha y equals negative 4 minus 1 over 3 minus 3. That means this one is undefined. I got an error. I'm going to quit, and I'm going to do my second one. 5 minus 1 over negative 4 minus negative 4, and I get another error, so that's undefined. Since they are both undefined, those mean there's the exact same answer, so my answer would be parallel. Okay, now I'm going to flip to the back, and if you would go ahead and pause, and you can write those things down for me. Okay, once you've written this, I'm going to start going over it. So now we're going to change up the instructions on you, and we're going to determine if the equations are parallel, perpendicular, neither. When you're looking at the equations, all you have to look at is the slope still. So it must be in y equals. Okay, so for the first problem, I got y equals 4/5 x minus 8. Since this is in y equals, all I'm going to look at is that slope 4/5. And then I'm going to look at the second equation, y equals negative 5/4 x plus 3. That one's in y equals also, so all I'm going to look at is that slope of negative 5/4. Okay, ask yourself these questions. Are they the exact same? Well, no, they're not. Okay, second question. Are they opposite signs? Yes, they are. And do the fractions flip? Yes, they do. So these are what we call perpendicular equations. Okay, when I look at number 2, I've got y equals 1/3 x plus 2. That's already in y equals, so I'm only looking at that 1/3. And I have y equals negative 1/3 x. That's in y equals, so I only look at the negative 1/3. Okay, first thing you look at, are they the exact same? No, because they're opposite signs. Second question, do they have opposite signs? Well, we already answered that. But do the fractions flip? The fractions do not flip, so this is a neither problem. Okay. Moving to example 3, I have x plus 6y equals 30. This is not y by itself, so the first thing you're going to do is move the x by changing its sign. That gives me 6y equals a negative x plus a 30. I'm actually going to add a 1 in on that x, so I know that there's a negative 1. And now we divide by the number in front of y, which gives me y equals negative 1/6 x plus 5. Okay, all I'm looking at is this slope right here. Now I'm going to look at the second problem. I have 3y equals 18x minus 6. Again, y is not by itself, but they already moved the x. So all we have to do is divide by the number in front of y. So I get y equals 6x minus 2. And all I'm looking at is the number in the slope position. And if you need to, go ahead and put it over 1 to make it a fraction. Okay, so now here's what you're looking for. Are the numbers the exact same, the slopes? No, they're not the exact same, so these are not parallel. Okay, are they opposite reciprocals? So opposite sign, flipped fraction. Yes, they are. So these are perpendicular equations. Okay, for 4, 3x minus y equals 2, move the x by changing the sign. That gives me a negative 1y equals negative 3x plus 2. Divide by the number in front of y. That gives me y equals 3x minus 2. And all I'm looking at is that 3, the slope. For 12x minus 4y equals 4, not in y equals, so we move the x by changing the sign. That gives me negative 4y equals negative 12x plus 4. Divide by the number in front of y. And that gives me y equals 3x minus 1. And all I'm looking at is the number in front of x, the slope. Okay, first question, are they the exact same? Yes, they are. So these are parallel equations. Okay, for number 5, you have y equals 6 and x equals negative 1. So since you only have one letter in each equation, it will help you if you draw yourself a graph. So here's my x-axis, here's my y-axis. Okay, I'm going to plot y equals 6. Well, 6 would be somewhere up here on the y-axis, and so my line would be going across like that. Okay, x equals negative 1 would be somewhere here on the x-axis, and my line would be going across like this. Okay. Now that I have my two lines drawn, I'm looking at my purple and my pink line. Well, those two lines are perpendicular, so I'm going to go ahead and put that those are perpendicular equations. Okay, now y'all are going to work on your worksheet, and if you have any questions, let me know.